Okay, so now I am sharing the screen. I have shared the screen. Uh, okay, you can start with this question. Okay, no, leave it, not this one. Not this one. Not even this. Okay, this one. Try this question. Try this. Question is visible to you? Understood the question? Question is visible or not?
The question is visible for me.
Okay, try this. You can ask your doubt.
So if we find the area, sir, we can say 110. Sir,
Sorry, can you repeat again?
Sir, if I find the area here,
Yeah, so
we
if you
can get
find
the work
EM,
done.
you will get the work done, right?
So it will be 1 plus 1.
And then also you can apply work energy theorem and you can say that work done by, the total force will be equal to change in kinetic energy, right? And then you will get that the change in kinetic energy is coming out to be how much?
So we get 0.25.
This is the change in kind work done. This is the work done.
Sir, total work done will be, which is equal to change in kinetic energy.
Okay, so 0.25. Okay. Now here you can
One
write
more.
that it is
Yes, sir.
K final minus K initial
Yes, sir.
is 0.25. And you know that from here we can find the K initial. That K initial will be how much?
It will be 0.25. No, sir. It will be K final plus 0.2.
K final plus or minus? K
Minus, sir.
final minus
Minus 0.25.
minus 0.25. Okay. And here you have to understand that the kinetic energy cannot be negative.
Yes, sir.
What do
Because
you
now
think?
we can it
So the
should be
minimum value
between
of K initial has to be
0%. So it will be minus 0.25. Sorry,
sorry minus 0.25 you are getting.
because here negative matrix.
Area under the graph is positive or negative?
And negative, sir. It is sorry. That's right.
Okay, the total that you are getting is negative, right?
It's a negative.
So this is negative. Then from here, what you are getting is K is equal to K final plus
Yes, yes.
0.25.
Okay.
है ना? And K final will be definitely greater than equal to 0, right? So from here you will get K initial will be greater than or equal to 0.25, right? You got the minimum value. Minimum value of K initial is 0.25. Understood? Are you getting it? Minimum value is 0.25. K initial. Understood? Not understood?
Understood, sir.
Hmm. because kinetic energy cannot be negative. So from here, the to get minimum value of K initial, K final should be also minimum. Now minimum value of K final will be 0. So you put 0 and you will get the minimum value of K initial. Okay. You can try this question. Try this one. Think about it. You understood the question? Question you understood? Tell me, Himanesh, question is visible to you? Sorry.
So what?
Your question is visible to you.
Yes, sir. Question is visible.
Okay, understood the question.
Yes, sir. Understood. Sir.
Okay, try this. You can ask your doubt. Tell me, Prabhakar, are you getting? Are you doing? Tell me, getting or not getting?
Sir, not getting, sir.
Okay. So here you have to calculate the work done by the boy against the gravity. Okay. So first of all, every time the boy takes the sand and put it into that bucket, are you getting? So the boy is doing some work in lifting the sand and putting it in the. Suppose that if there is no spring, suppose only the boy lifts it and put it at some height. There is no spring here. Then the work done against the gravity will be simply mgh, right?
Sir, what? Sir, but
If
your screen is
suppose,
there, no, sir. Yes.
sorry, yeah. So I'm saying that suppose that if there is no spring, in that case, first think about that case. So suppose if there is no spring and the boy is transferring the mass to this container, then in that case work done against the gravity will be simply mgh, right? Because whatever work he did, that led to the increase in potential energy of that sand, right? Now in this case, because there is a spring also, so what is happening here that whenever he will put some sand in the container will also go down a little bit, right? When the container will go down, actually the potential energy, so work done by the person is mgh, but then it loses some potential energy. But the thing is, because the bucket goes down a little bit, right? But the thing is, it loses some potential energy, but then it gains some spring kind potential energy. Gravitational potential energy it loses, but it gains the spring potential energy. So if this bucket goes down to a distance x, finally suppose distance x. So what we can say is that the work done against the gravity by the person is simply changing the gravitational potential energy, but because it loses some gravitational potential energy, and that loss of gravitational potential energy is actually not lost, it is stored in the spring in the form of a spring potential energy. So the work done is actually in this case will be equal to change in its gravitational potential energy plus the change in a spring potential energy. Whatever work the person is doing, what happened to that work? So that work gets stored in the system in the form of potential energy. You can say there is no, है ना? Means when the person is putting the sand to the bucket, work done is equal to change in potential energy. But then it again goes down. Bucket goes down by some distance. So it transferred some amount of potential energy to the spring. because the bucket and the sand loses some potential energy, gravitational potential energy, but a spring gains the exact amount of spring potential energy. So whatever work is done here gets transferred into है ना, into the gravitational potential. So some of the work है ना, is stored in the form of gravitational potential energy of the sand in the that pan, and some amount of that gets stored in the spring. Are you getting it? So that's it. Now, what is the gravitational potential energy? Change in gravitational potential energy. So we are talking about finally, overall when he transferred. So the change in gravitational potential energy is simply mg into L by 2, L naught by 2. So the work done will be simply is equal to whatever is the mass m g into L naught by 2 final gravitational potential energy, and plus where is the remaining amount of energy. So remaining amount of energy is stored in the spring in the form of half k, and x is also L naught by 2, L naught by 2 whole square. This is the amount of work done against the gravity. Tell me, are you getting it? So total work done by the boy will be actually found as gravitational potential energy of sand plus elastic potential energy of the spring. Now you can ask your doubt. If there is no spring, only a pan, then this term will not come. Total energy will be stored as gravitational potential energy of the sand. But because the pan is coming down little bit, so it is losing some amount of gravitational potential energy, and that amount is transferred to the spring. So ultimately the energy is stored in a spring also, gravitational potential energy also. Tell me, are you getting it? Or do you have any doubt? If you want, you can also simply understand it by applying work energy theorem. Are you getting? Are you there?
I'm getting.
Okay. You can also think it in the form of work energy theorem, that but the thing is that work energy theorem, why we are not using, because using work energy theorem will not be easy here, because work done against the gravity, because the person is taking sand to different height. because every time you put some sand, the bucket goes down by a small height, some height. Are you getting? So every time the height is changing. So he is putting the sand, but the pan is going down, right? So it will be better if you use this. You can ask your doubt. You have no doubt, right? See, whenever some work is done by the external force, that work done will be equal to change in mechanical energy of the system. But because here there is no change in the kinetic energy, see here, no change in the kinetic energy. So whatever work is done, that will simply cause change in potential energy of the system. Because anyway, change in kinetic energy is zero. So that's it. So mechanical energy of the whole system, if you think, means sand plus the spring plus that pan. External force is doing work on the system. That work done will be equal to change in mechanical energy. Change in mechanical energy is the same as change in potential because kinetic energy is not changing here. Understood? You want to say something? Okay, can we go to next?
Yes, sir, you can go, sir.
Okay, so let's go to the next then. Now try this question. You can ask your doubt. Oh, I think question is only half part is there. So the remaining part is this. This is the remaining part of the question. Can you see this question?
So cancel the previous. Sir, I can see.
This one?
That's what I can see, sir.
Okay. This is the remaining part.
Visible, sir.
Yeah, now it is visible to you. Question is
Oh,
visible.
it's not visible. One.
Okay.
8, sir.
Tell me, Prabhakar, you have any doubt? You understood the question?
Sir, MGL by 8, understood, sir.
MGL by
8, 8, sir.
MGL by 8 you are saying.
Yes, sir, 8, sir.
Okay. So you are saying MGL by 8. That is not correct. Work done against gravity MGL by 8 is not correct. So tell me the process.
Sir, work done is under change in potential energy.
Yeah.
So, I found initial, if we find initial potential energy and final state, by subtracting we get the work done as right.
Final what? Final, you are said final what? Final?
So, I'm waiting, sir, initial and getting a final state.
How you calculated final? Potential energy. Mg
So,
into, yeah.
height will be L by 4 muscles, sir.
Height of what?
Ah,
Height of what? Mg into,
L by 4 height of the center,
speak
the
little
distance.
clearly. Yeah, you are not audible, like clearly, loudly. Speak louder. Yeah. Now mg into,
So, L J into L by 4, so the distance of the N part travel is equal.
L by 4 you are saying.
Yes, sir, L by 4, sir, because the distance traveled by that part is considered, sir, end of system.
Which part?
Sir, the end of system, I mean,